All right, let's try this one more time. Had a little technical difficulty. Let's go through it one more time. What was the first one? Circumcenter. The second one, orthocenter. Then the third one yesterday was in-center, and today is centroid. Okay, so let's try this one more time and talk about a word. There we go. Now it's working. We want to talk about the median of something. You're going down the road, right? Driving down the road. Not every road has one, but a lot of roads do. Let's say you're going down Route 40. You've driven down Route 40 a bunch of times, haven't you? Have you been on Route 40? Route 1, right? If you live in Middletown, you go to Route 1. There's 2 lanes of traffic, right? One going south, one going north. What's in the middle? Big grassy area in the middle, right? What do we call that grassy area? Just call it the middle? We call it the what? We call it the median, exactly right. Why do you think they call it the median? Because it's in the middle, right? Route 40's got a big grassy area in the middle. A lot of these big roads go down 95. You got a big old space in the middle, right? So the cars don't crash into each other. I guess it's probably a safety thing, is my guess. But they call that the median. I remember back, I don't know, it was college maybe or something like that. We had this Thanksgiving Day football game for like the people at our church. It was like the youth group or something like that. And the youth pastor of the church, the ball, it was next to William Penn High School. That's where my church is, or was. It's where I used to go to church, let's say that. Anyways, next to William Penn. Next to William Penn, yeah. It's a big building. Yeah, that's where I went to church. That's where I grew up my whole life, at that church. Then about 3 years ago, I left there, and now I'm at a different church. But we were playing in one of the fields there, and the ball went out into the road, and the youth pastor said, "Oh, look, the ball went into the medial strip." The medial strip. And I've heard several people say that, but they just don't hear the word correctly. You know, it's median. Medial, that might be a word. Like MCL, what's that? Is that a medial something ligament? Anybody had an MCL surgery or anything? Athletes? Nobody? Anyway, it might be medial. I'm not really sure. But anyway, the word is not medial. Shh. Listen. Let me just tell a story and be able to just continue without me stopping you. Could I just please do that? It'd be really nice. Thanks. So, it's not a medial. It's a what? It's a median. MEDIAN. All right. Even back then, I was young. I might have been in high school, and I remember thinking, "No, that's not right." But I'll just let him say it. He was my youth pastor, you know, so I wasn't going to correct him. But anyway, it is median. Median. All right. It's in the middle. So what does that mean? Well, on a triangle, I'll tell you what. Let's let's draw a triangle. I was thinking about going to GeoGebra right away, but let's do this first. Then we'll do GeoGebra, so you have this might make a little more sense. So what I'm going to do is I want to draw the medians of this triangle. All right? So where do I start? To draw a median, I start at a point, and I go to the other side. Where to the other side? What do we say median is? The grassy part in the what of the road? The middle of the road. So if I start right here and I want to draw a median, where do you think I'm going to draw it to? The middle of the triangle? Is that the middle of the triangle? I don't know. Is it? Where do I want to draw it? To the middle of the what? What do you think? I'm going to draw a line from here. Am I going to draw it out here? Watch. Let's draw a line. Am I going to draw it out here? Am I going to draw it here? Am I going to draw it to the middle of this? That's a possibility. Am I going to draw it to the middle of this? Now, where do you think it's going to go? It's going to go through the triangle. Where do you think? To the middle, or what do we say, though, in geometry? The whole thing is the median, but where do we draw it to? We draw it to the midpoint of that side. So, what do we need to do? I need to find out where the midpoint is. Luckily on this program, I can just highlight it. See that little blue dot right there? We don't just call it the middle of it. What do we call it? The midpoint. So that's the midpoint. So now, if I draw a line from a point right here, that vertex, from the vertex to the middle of the opposite side, to the midpoint of the opposite side. Everybody see that? What is that red line right there? That is the what? It's the median. That red line is the median. Now, is there just one median on a triangle? No, because how many vertices are there? There's 3 of them. So there's 3 midpoints. I'm sorry, 3 medians. So let's do this. Let's draw this, or let's highlight it. There's that little dot right there. I'm going to put a dot where that little blue one is, and I'm going to do it over here as well. I'm going to do this on GeoGebra as well, just to show you something else. All right, and we'll keep it all red. Keep all the medians red. So how do I draw another median? Well, I go from one vertex. I've already gone from that vertex, right? So I don't have to draw another one from there. Here's another vertex. I draw it there. Where do I connect it to? I connect it to what? The midpoint of the opposite side. Everybody see it? See? This side is next to this side. They're not opposite. This is the opposite side right here. Where do I draw it to? Right here? Right there? Do I draw it perpendicular? No, that's an altitude, right? There's a difference. Where is this going? To the midpoint, okay? It's kind of similar to altitude because you go from a point to another side. But altitude, what do? You go from a point, how do you hit the other side on an altitude? You hit it perpendicular. Very good. All right. On a median, where do you go to? You go from a vertex where? To the midpoint of the opposite side. All right. If I said that enough, I've said it several times already. Hopefully you get it. Let's do one more. And guess what? Okay, it's not much of a wild guess because we've done it 3 times already. Guess what's going to happen with that third median? What's it going to do? Diego, you watching? Doesn't look like you're paying attention. Start from the vertex. Where do you think it's going to do? It's going to go to the midpoint of the opposite side, but what kind of special thing do you think it's going to do that all 3 of the other ones did? It's going to meet at one point. What do we say about those 3 lines? We talked about this yesterday and the day before. We use a word. If 3 lines all connect at one point, we call those lines what? Concurrent. Very good. Neil is paying attention, all right, and he's remembering. So watch. If I go to the midpoint, check it out. They meet right there at that point. Everybody see it? That point is a special point, and it's called, what do you think? Come on. Look at the thing. No, the medians are the red lines. The point itself, where they meet, where they're concurrent. It's the centroid. Very good. It's right in front of you, okay? It's called the centroid. So this point right there is the centroid. There is something special about the centroid, but I want to go to GeoGebra and use GeoGebra to show you, okay? So basically, I'm going to do the same thing as I did right here, but I'm going to do it with just a different program, okay? So let's go to GeoGebra. Click on that. Now I got to change it so anybody watching YouTube, all my ones of viewers that watch my YouTube videos can now see it. Oops. There we go. That's what I want right there. Okay. So what am I going to do? I'm going to draw. Oops. I keep forgetting I can't use the pen on this GeoGebra. It's weird. I don't know why. It seems like it would be the same thing. So I'm just going to draw any triangle. Doesn't matter. Right? Nothing special about it. Let's move it over here. So what am I going to do? I'm going to draw the medians, right? How do I get a median? I find the what first. Before I start drawing lines, what do I find of each side? Find the midpoint of each side. So let's do that. So there is a thing right there. Look at that. Midpoint or center, it says. So I'm going to click that. And all I do is click this line, and guess what it's going to do? It's going to give me a point where? In the middle, at the midpoint, right? So watch, I click anywhere on this line. I don't have to like estimate where the midpoint is. I can click right here, and boom, it puts point D. Guess where point D is on line segment AB? It's at the midpoint, exactly right. So watch, I'm going to make a midpoint there. I'm going to make a midpoint right there. And those points, D, E, and F, are all exactly at the midpoints. Everybody got that? So now what I'm going to do is I'm going to connect this vertex. So I just make a segment. I connect from A to what? Where do I connect it to? A to F. Very good. A to F. That's going to be a median. So that's one median. Everybody got it? It goes, again, I'm repeating myself a lot, but listen, maybe one of these times it'll click. I go from a vertex to the midpoint of the opposite side. Yes? All right. Let's do it again. I started at A. What's the next place I want to start? Let's go to B. And I'm going to connect from B to what? To E. And that's what? What's BE? BE is a median. Okay. Now I'm going to connect from what? C to D. And check it out. They intersect right at that point right there. Let's name that point. So I'm going to make it a point, put it right there, and I'm going to click on this, and I'm going to name it. What am I going to name it? Not point G. I'm going to name it what? Centroid. Okay? All right, so that point right there is the centroid. Now, on the other ones, at least two of them, I erased all the lines, and I said there's something special about that point, right? There's something special about the circumcenter. There was something special about the incenter. There was nothing special about which one? The orthocenter. There's nothing special about the orthocenter. But there is about the circumcenter, there is about the incenter, and there definitely is about the centroid. But I want to keep these lines here because I want to show you something. I am going to do this. Instead of one straight line from there to there, let's actually I'm going to get rid of, oops, I don't want to do that. There we go. Actually, I am going to get rid of these. Bear with me for just a second. All right, so don't start talking. Don't start doing your own thing. Just watch what I'm doing. Okay, I'm getting rid of all these lines, and I'll show you why in a second. All right, everybody watching? Even though I told you everybody don't do anything and watch, I still hear people talking. What I'm going to do is draw a line segment from A to the centroid. Everybody see that? And then I'm going to go from the centroid to F. You're like, well, why did you do that? Well, I took it, instead of making one just full straight line, I broke it into two pieces. So these are two different lines. I got A to the centroid. I got from the centroid to F. They're two different segments. Okay? You see what I'm doing? Let's do the same thing. I'm going to go from B to the centroid, and then I'm going to go from the centroid to E. Then I'm going to go C to the centroid, and I'm doing this for a reason, I promise. Then from the centroid to D. All right, now, here's what I'm going to do. I want to find the length. Now, let's everybody look up here. I still see people with their heads down. I see eyes closed. I need your full attention, all right? I want you to take a wild guess. You may not be able to guess it. It's fine, all right? But some of you might guess it. What do you think is possibly true about A to the centroid and from the centroid to F? First of all, are they the same distance? Do they look the same? Obviously not. A to the centroid looks what compared to the centroid to F? It looks longer, doesn't it? In fact, it is longer, okay? So from the vertex to the centroid is always longer than from the centroid to the opposite side. Everybody see that? Same thing here. B to the centroid definitely looks longer from the centroid to E. In fact, it's exactly how much longer than the shorter side. What do you think? Like from A to the centroid and from the centroid to F. If I was able to pick those up, A to the centroid is how many times bigger than this one right here? It's 2 times. Exactly. It's twice. Right. This one right here is twice as big as this one right here. Or you could say, Emma, what'd you say? This one, the short one, is what? Half of the long one. Everybody hear me on that? All right. So the long one is twice as big as the short side, or the short segment. We'll call them segments, okay? So the long segment is twice as big as the short segment. Or you could flip it around and say the short segment is what? Half of the longer segment. You get me on that? We'll actually put the numbers here in a second. Actually, let's do it right now. All right? I can go distance or length. So if I click on this, it's going to give me the length from A to the centroid. It's about 8.1. All right? So now I'll tell you what. Let's make this. It gives you one decimal place. Let's make it an 8 just to make it a little nicer. So if from A to the centroid is 8, What do you think it is from the centroid to the opposite side? It's going to be 4. So watch. I'm going to click on distance or length. I click on this, and boom, there it is. It's exactly 4. You see it? So that length, that long length right there, I should say this. The length of the longer segment is twice as big as the length of the smaller segment. That's basically, Evan, that's basically what you need to know on a quiz and a test. All right? Know that it's the centroid, and know that this one is twice as big as this. Or this one is half of this. Or, watch this. What's the length of the whole thing? The whole median, AF. It's 12, okay? What's the length of the shorter one? It's 4. So the shorter one is how much of the whole thing? Is it half of the whole thing? No, it's half of the longer one. Now, it's not a quarter. It's one what? 1/3, because it's 4 out of what? Are you listening? What was the whole thing? The whole thing was 12. This part was what? 4. So it's 4 out of 12. What's 4 divided by 12? It's 1/3. It's 1/3. So, here's another thing. The shorter one, listen to me, the shorter one is 1/3 of the whole entire median. You hear me? The shorter one is 1/3 of the whole median. But you're probably thinking, wait a minute, Mr. Hamrick, you said it was half of the other one. Well, it's half of the longer segment, but it's 1/3 of the whole entire median. Have I confused you yet? Okay. All right. Again, the whole thing is 12, correct? This one is 1/3 of the whole thing. What's 1/3 of 12? What's 12 divided by 3? It's 4. Okay? That works, doesn't it? All right? So again, know your relationships. This one is 1/3 of the whole median. What about 8? How much of the whole median is 8? Exactly right. Good. I'm glad you got it right away. It's 2/3. So the longer leg, or the longer segment is 2/3 of the whole entire median. You got it? But it's only what? Twice the shorter segment. Right? So the 8 is twice 4. Agreed? 8 is 2 times 4. But 8 is 2/3 of 12. All right? So there's a lot of things to know about that. Let's continue with the other ones. Let's find the length of that. Oops, it's not what I wanted. I got to hit distance. That's what I want. Okay, hit that one. It's 5.5. Now again, 5.5 is kind of hard to do that, but it's kind of hard to take half of that. But I'll tell you what, let's just make the triangle. So, oops, not what I wanted. Let's do this. Let's make it, there we go. I'm going to try to make it a 6. There we go. Now, that changed the other one, but still, look. It changed the other one, but this is still twice as big as this, isn't it? Right? 7 is twice as big as 3.5. Yeah? Okay. But, oops, I moved it, didn't I? Let's make it 6. So, everybody watch this. If the length of this is 6, what's the length from the centroid to E? It's 3. What's the length of the whole median from B to E? It's 9. You got it. Everybody see that? That's basically what they're going to do. The hardest part is when they give you the whole thing. What if? Here, I'm going to put the 3 there. Oops, not what I wanted. Let's try this one more time. Let's go to distance or length. Let's click this. There we go. There, it's 3. It just shows you it's 3 right there. I didn't type in 3. The computer program actually came up with me in 3 because they know that this is half of this. All right? What if I told you the length of the whole thing? What if I told you the length of the whole thing was 9? You with me? That's all I told you. Okay, but I told you this is a centroid. How could you get 3 out of that? Because remember, the shorter side is 1/3 of the whole entire thing. If I tell you the whole thing is 9, then how do I get that 3? It's 9 what? Divided by 3. That's right. 9 divided by 3 is 3. What if I told you the length of the whole thing was 15? What would the length of this little bit right here be? If the whole thing was 15, what is the shorter one? It's 5. What math did you do? 15 divided by 3. Okay? Everybody see that? So forget the 2/3 one. All right? You could do that. In fact, in the book, when they write out this theorem, I believe they say 2/3. I think that's the most confusing way to explain this theorem. All right? You may think that I'm explaining this confusingly anyway, but watch. If the whole thing is 15, how much is the shorter side? It's 5. Why? Because 15 divided by 3. Remember, because the shorter side is 1/3, right, of the whole thing, right? What if the whole thing's 21? What's the shorter side? 7. What's the longer side? 14. You got it? That's the hardest part of this problem is when they give you the whole thing. And it's not that hard. Well, as long as the number is divisible by 3, all right? It's not too hard, all right? What if the whole thing, here we go. What if the whole thing was 30? What's the longer side? How'd you get that? You went 30 divided by 3, so that's the short side, right? And then you just double it, and that's the long side. Exactly. Everybody got it? Okay. So, yes. Bring your pass up. What's that? I can't hear you. What? No, you're right. I'm almost out of them, and my throat's starting to get a little scratchy. All right, so let's go back to this. Let me change it on the YouTube. There we go. Let me sign a pass. All right. So this is the kind of stuff that they're going to tell you. Let's take a look. Everybody watching now? Now, I went through it, but I just did it verbally. I want you to see it visually. All right? See it visually. I guess you could only see it visually, couldn't you? So what if I said, we'll call this A, B, C, and let's just make this different color. Let's call this D, E, F. Okay? So what if I told you that A, F, and we'll stick with numbers that are fairly easy. What if I told you that line segment AF, and I told you that this was, let's do this. Boom, boom. We'll make that, we'll make that. This is all I told you, okay? I didn't even tell you what that point is right there, but you should be able to figure out what that point is, okay? How do you know what that point is? Well, you know it's a centroid because we're talking about the centroid. But what if I didn't tell you? What if they were all mixed up? How would you know that's a centroid? Because what is A to F? Starts at a vertex and it hits where? At the midpoint, right? So if it hits at the midpoint, then it's a median. If it's a median, then it's a what? Centroid. You got it? Okay? So you know that these are all medians, so you know that this point where they all intersect, where they're concurrent, is a what? Is a centroid. So you know that's a centroid. So every time we do a centroid, that's where we do the long side is double the short side and all that kind of thing. All right? So what if AF is 18? I want you to find X and Y. Okay? Emma? Okay, how'd you get 6? Y is 6, she said. Pretty easy. How'd you do it? Exactly right. It's really simple, isn't it? Okay? Once you see it, it's really simple. So 18 divided by 3 is what? 6. So that means the shorter one is what? 6. Then obviously, the longer one, well, obvious. Is it obvious? It should be, because I've said it a bunch of times already today. But what's the longer side then? Just anybody tell me. It's 12. All right? How do I know it's 12? Because it's twice the shorter side. If you know those relationships, it's not that hard at all. Do you agree? Yeah. Now, as long as these numbers are divisible by 3, it makes it really nice, all right? And I don't know, even if it's not. What if I told you that BE was 20? Okay? What is, we'll call that little a, we'll call this little b. What is little a equal to? Well, what do we do here? We took the whole thing and we divided by what? I want you to find a and b. Let's find this first. That's the easiest one to find first. Okay, say it. Tell me out loud what you just said to yourself. 20 divided by 3. But it also is just 20 over 3, isn't it? Okay. You watching, Judah? All right. So this little a is 20 over 3. Does it reduce? Doesn't reduce. Just keep it like that. All right. Emma, you said it was like 6 point something, right? I don't care what the decimal is. All right. This is an exact answer. All right. 20 divided by 3. If you wrote it as a decimal, it would repeat anyway, right? And we don't care about that. Okay. This is an exact answer right there. So just leave it like that. It actually is pretty easy. In fact, it might be a little easier than just going 18 divided by 3 because you actually have to do some math to come out with 6. Do you see that? Right here, do you have to really do any math? No, it's just 20 divided by 3. You just leave it like that. But now, it's a little tricky. How do you find b? If this is 20 divided by 3, or 20 over 3, or let's think of the other way. Don't think of this as half of b. Think of b as what? Not half. It's twice as big as a. Think of it that way. I mean, you are right. A is half of b. That's absolutely true. Nothing wrong with that. But it's a lot easier to look at it as b is twice as big as a. So b is twice, 2 times what? A. What's a? 20 over 3. That's actually fairly easy. How do I do this math? Nobody likes fractions, but this is an easy fraction. It's 40 what? Over, not 6. This is 2 over 1. Okay, this is 2 over 1. You multiply the top, multiply the bottom. All right, it's 1 times 3. So it's not over 6. It's 1 times 3, which is 3. So this would be A, and this would be B. They're ugly numbers, right? I don't like them either. Okay, I would rather have a 6 and a 12, wouldn't you? Absolutely, we all would. But life doesn't always work out that way. All right, this is what we have. And that would be your answer for something like that. That's the hardest that this problem gets. Everybody hear me? What's like an easy version of this problem? Let's get rid of some of this mess. Let's get rid of this. Let's get rid of this. Let's get rid of all this mess right there. There we go. Oops, missed that. All right, what's the easiest version of this? Well, I say if they told you the short one, I think that's the easiest version of this problem. Give me a length for this short side right here. No crazy big number or anything. Just give me what's the length of that? Just give me a number. I'm not saying find it because I don't know. Just make up a number. Give me a number. 6. Well, we've already used 6. Okay, 8. All right, let's use 8. All right, so if that's 8, what I want you to do is I want you to find, and this could be a quiz question or something like it. Okay, I want you to, what's this letter in the middle? Let's call it EF. Let's call it G in the middle, okay? So what I want you to do is I want you to find what BG is equal to, and I want you to find what BE is equal to. This is the easiest version of this problem, all right? So what's BG? Say it. 16, exactly right. How did I know that? Because the longer side is 2 times the shorter side, right? So BG is 16. And then BE is what? The whole thing. It's 24. Very good. So very easy. Would you agree? Now, they could have done this. They could have said, let's get rid of this. They could have told you that BE was 24. Now, you should know what these numbers are because we just did it. I just erased them, okay? So, what if they told you the whole thing, BE, was 24? What's the first thing that you would find? No, not GE, right. I would find GE. How do I find it? What math do I do? If I know the whole thing, from there to there is 24. How do I find GE, which is the shorter side? You got it. It's 24 what? Divided by 3, which is 8. And then BG is super easy now. Once you got the short side, then you're good to go. What's the long side then? BG. It's just 16 because it's 2 times what? 8, which is 16. Everybody see that? Those are the 3 versions I'm going to give you. There's no other way that I could give you that problem. All right? Either I give you the short one. Oh, I could have done this. I could have given you the longer one, right? So let's do that just for fun. Okay, let's get rid of that. Let's get rid of that. All this mess. Okay, this is the last type of problem. Let's introduce another color here. I could give you. What if I told you that this was 10? So BG was 10. And now we've hit every possible combination of ways to ask this problem. What if BG was 10? What's the first thing you would find? Find GE. That's right. So if this is the longer side. From the vertex to the centroid is always the longer leg. Or not leg. I keep saying leg. It's not really a leg. It's a segment. It's the longer segment. Okay? So what's GE then? 5. That's right. Because this is the longer one. The shorter one's half of the longer one. And what's the whole thing? What's BE? BE. That'd be 15. It's as easy as that. You okay with that? Yeah, not bad at all. All right. I'll tell you what. We got a few minutes, so let's use it wisely. And let's do a little review. In fact, just wait till we do this review. There's a chart on page 216. Everybody look at, well, you don't have to look. If you don't have your book with you, at some point, write this down in your notes, though. On page 216, there's a chart. I think at one point I had actually taken a picture of it and stuck it on the computer, but I don't want to sit there and look for it now. So let's list. I'll basically just do this chart for you. All right. So our 4 words. Our first one. I would write this in your notes because this is all in one place. It's all compact, right? So you don't have to go flip through your notes and look for all 4 of them. So put this in your notes. Maybe even put it on a separate paper. Like if you're halfway through it, maybe flip the page. Just use one sheet of paper for these notes, okay? So the circumcenter. How did you find, tell you what, I'll do these in different colors. How did you find the circumcenter? What did you do to find the circumcenter? You found the what? Perpendicular bisectors. Perpendicular bisector. That's how you found the circumcenter. Now, there was something special about the circumcenter. Let's do green. There was something special about the circumcenter. Do you remember what that was? You got it. It was equidistant from the vertices. We're just going to write them down so you can see it. All right, everybody good with that? So that was what you need to know about the circumcenter. What was the second one that we taught? Orthocenter. Do you remember how we found the orthocenter? We found the altitudes. That's right. So you draw the altitudes. I'm not going to go through the whole explanation what an altitude is, but that's what you need to know. Okay, that's how you found the orthocenter. What was special about it? In green is the special one. What's special about the orthocenter? There's nothing special about the orthocenter, except for the fact that they all meet at one point, but all 4 of these all meet at one point, don't they? All right, so other than that, there's nothing special about the orthocenter. What was the third one, the one we did yesterday? That was the incenter. And how did we find the incenter? We found the Remember? It's not the median because we just did median. Yes. You did say it. That's correct. You find the angle bisectors. I was just trying to figure out how to write it. So you want to find the angle bisectors. Now, there was something special about the incenter. Do you remember what that is? It's not equidistant from the vertices. It's equidistant from the sides. It's equidistant from the sides. I thought I could fit all four. I'm going to have to scooch down a little bit. All right? Everybody with me? And now, the one we did today was the what? Centroid. Okay? The centroid. And how did we find the centroid? The medians from the vertex, is that what you said? Yeah, we'll just say medians. Okay? So you found the medians. And you found that they intersected in one point, correct? And that would be the centroid. Now, there was something special about the centroid. We'll just do it like this. We'll say that the long segment is how much of the short segment? 2 times the short segment. Now, the book, they use the 2/3 thing, which I think can be confusing. All right? I think if you know this, I think that's the best way. Or you could look at it like this. The whole median, I'll put this, the entire, they don't write this in the book, but I'll write it down. The entire median is equal to, I'm sorry, I should have written it the other way. Let's do this. We'll say the short segment is equal to what? The short segment on a median, with the centroid thing. The short segment, is it equal to the whole entire median? Of course not. Is it half the median? No. What's the short segment? It's what? It's 1/3. It's 1/3 of the entire median. So anyway, this should help you out a little bit. All right, if you wrote it in your notes. If not, it's on page 216. Again, with the centroid, they do that 2/3 thing. It's 2/3 from the vertex to the opposite midpoint. I think that's too confusing. I would rather use this right there to remember what's special about the centroid. All right, so you do have a homework. You're supposed to do yesterday's, so we'll make it one big homework assignment. What? So it's section 5.2. We'll just call it 5.2. And we're going to go 1 to 12. So it's basically both of them. Let's do this. Let's do them separately so that you can get 10 points instead of 5 points, right? We're getting into the marking period. You guys are going to need your points, correct? So if you do it, it'll help you out. Now, if you don't do it, it'll hurt you worse. But if you do it, it'll help you out. So let's do section 5.2a is 1 to 12. And then section 5.2b is 23 to 37. All right. You got a whole weekend to do it. So do the first one tonight. Do the second one on Sunday after you get back from church, okay? So that's what you're doing.